So this welcome page and syllabus that we just talked about, you get to that to see the syllabus again by clicking here on this one, going to this link, or by clicking this small house up here. So what is HPC2N? Well, HPC2N is High Performance Computing Center North, and it's a competence center for scientific and parallel computing. It's part of the National Academic Infrastructure for Supercomputing in Sweden, which is called NICE. And if you have heard of SNCC, that is the precursor to NICE. So HPC2N provides state-of-the-art resources and expertise. We have scalable and parallel HPC. We have large-scale storage facilities. And there is grid and cloud computing. The grid computing is for the WLCG, where we are tier 1 node. And that is for CERN, for that group down there. And the Swedish Science Cloud is what we are part of as well for cloud computing. HPC2N is also a national data science node in epidemiology and biology of infections. That is the data-driven life science, or DDLS, that we do together with SciLife Lab. We have some software for e-science applications, quite a lot of it, and we have all levels of user support. So HPC2N's primary objective is to raise the national and local level of HPC competence and to transfer HPC knowledge and technology to new users in academia and industry. HPC2N is hosted by Umeå University, and we have some partners. Our partners are IRF in Kiruna, that is space physics. We have Luleå Technical University. There's the Mid-Sweden University in Sundsvall. And then there's SLU, there's also here in Umeå. And HPC2N is mainly funded by Umeå University, but we get contributions from the other HPC2N partners, and now also NICE. We are involved in several projects and collaborations that you can see here. And then let's talk a little bit about the HPC2N training and other services. We have the user support, primary support, advanced, dedicated. We have research group meetings, which also are at the partner sites. We have the online HPC2N FICA, and we also now have what is called the intro seminars. Both are for new users or potential users, though the HPC2N FICA is more for current users who want to hear a little bit about what's new at HPC2N and maybe also talk a bit about their research, ask questions, get to talk to some of the support staff here. So for the training, we have the courses. There are some that are half a day up to 5 days. We have intro courses for system, for Linux, R, Python, Julia, MATLAB, Git, many other things. And we also have intermediate courses. Many of these courses are given in cooperation with other HPC centers in Sweden. And this is a list of some of them. You can always find an updated list at this address here. And then there are some workshops and seminars. And we also take part of some university courses. So let's go through HPC2N's personnel. We have the management. We have Paolo Biantinesi, who is the director, and Björn Torkelsson, who is the deputy director. And then we have Lina Hellman, who is the administrator for HPC2N. There are currently 4 application experts. There's Jerry Eriksson, that's Pedro and me, and then there is Åke Sandgren. There are also system and support. The people in bold are people who are both system and support and application experts. And then we also have a number of other people with HPC2N. We have the WCG coordinator, that was the grid computing. And then we have research engineers that are under DDLS that are connected with the SciLife lab. I'm going to go to talk a little bit about HPC2N users by discipline. And as you can see here, we have users from several scientific disciplines. What we don't have a lot of are people from the humanistics. And we also don't, we mainly actually have from TechNet, technical and natural sciences. And we would probably like to have more from also other parts of areas. And those who are here in bold are the ones that are the largest groups or largest users. And you can also see here, this is a pie chart for software at Kebnekaise, what is used most. And you can see CP2K and GROMAX are really used a lot, but so is VASP. And what is named as Atlas, that is the grid computing. Unclassified is software people have installed themselves or developed themselves. That is not part of the module system, but we'll talk more about the module system. So what is Kebnekaise? The current supercomputer at HPC2N, and it's a very heterogeneous system. It's named for a massif in northern Sweden that has some of Sweden's highest mountain peaks. We got it in 2016, so it's not new anymore, but we have replaced a lot of the hardware in it. And you can see here it has been extended several times in 2018, in 2023, and in 2024. And we also retire old hardware. So it will be continuously upgraded, and that is the plan. It has some CPU only, some GPU enabled, and some large memory nodes. And the CPU only nodes are some Intel Skylake nodes. We also have AMD Zen 3 and Zen 4 nodes. For GPU nodes, we have Intel Skylakes with NVIDIA V100s. We have AMD Zen 3s with NVIDIA A100 or with AMD MI100s. So we also have a small number of AMD DPUs. The rest of the GPUs are on AMD Zen 4 nodes. So it's NVIDIA A6000, NVIDIA L40S, and NVIDIA H100, and some NVIDIA A40s. And some of these nodes are also good for AI, and but also some are good for general computations. It just told me that it finished converting the recording from the previous course. So this is the large memory node. It has quite a lot of memory, but we don't have a lot of nodes of that, but it's possible for those who really need a lot of memory. GPUs can have different types of cores. There are CUDA cores that are general purpose cores for various parallel computation tasks. There are tensor cores that are made for matrix multiplications, and they are good for deep learning and AI. Of course, you can also use them for general purpose, but they may be less efficient for that. And tensor core is the NVIDIA name. And AMD calls them matrix cores. RT or ray tracing cores. There are something that's on a very small number of newer GPUs, and they are optimized for things like ray tracing, for rendering images or video. And I have a small table that I've collected here, where you can look at which types of GPUs have what. And it may help you to figure out which types to run on, depending on what your code is. But of course, you can't really compare them directly because there could be newer ones, could have more efficient design and be faster, etc. So HPC2N has several types of storage. We have the home directory that has 25 gigabytes user-owned storage. That is the home directory you get to when you just logged in. And that is also called $home, or it's in /home/ first letter of your username / your username. Then there is the project storage, which is /proj/ no backup / the name you picked for your project storage. And here I picked intro minus HPC2N. And that's shared among project members, which is why you should create your own directory under it, so that your files don't get mixed with everyone else's. Other than that, there is local scratch space on each node, and it's volatile, meaning that after the job has run, the scratch space disappears. The content of the scratch space disappears. HPC2N also has tape storage for backup and long-term storage, but it's not directly user available. And then you can also use Svestore, and mainly that is used for the data storage infrastructure. So on Kebnekaise, how do you get to use it? Well, you need to have a project. You need actually to be a member of a compute project. And a compute project has a certain number of core hours allocated for it per month. A regular CPU core costs 1 core hour per hour. Other resources like GPUs cost more. And cost is to the project. It's not a monetary price. It's free for academia to use. It is not a hard limit, the allocation you have, the core hours you have. Projects can go over it, but they get lower priority to start jobs. So it takes longer until some time has passed. And these compute projects, they contain a certain amount of storage, usually 500 gigabytes. If you need more storage than that, you must be a member of a storage project that you can apply for as well. And one thing to notice is that as Kebnekaise is a local cluster, you need to be affiliated with either Umeå, Kiruna, SLU, Mion, or LTU to use it, or rather to be a PI for it, because the PI can have can add users from anywhere. Projects are applied for through super, this address here that you used to create your super user. And I will talk a bit more about it later, but first I will continue to say a little bit about HPC. So what is HPC? Well, the definition of high-performance computing is that it most generally refers to a practice of aggregating computing power in a way that delivers much higher performance than one could get out of a typical desktop computer or workstation in order to solve large problems in science, engineering, or business. So HPC2N Kebnekaise cluster has a total of 95 nodes with 4,792 CPU cores and 84 GPUs. And there is a lot of CUDA cores, tensor cores, matrix cores, and RT cores. And if you compare that to maybe 4-8 cores in a normal modern laptop and maybe 1 GPU, that is a lot more. And that, of course, also leads to a lot more arithmetical operations per second than in a modern laptop. So when does a problem become large enough for HPC? And are there other reasons for using HPC, like memory and software and support, etc.? Well, a problem can be large for two main reasons. It can be large in that the execution time is very long. Or it could be large because it needs a lot of memory and a lot of storage. That is one way. To get the execution time down, you could increase the performance by adding more cores, more GPUs, and things like this. And if it needs a lot of memory or storage, you could add more memory, more storage. Kebnekaise has quite a lot of memory on the nodes, as you can see here. So you could show that as a diagram, what counts as HPC. Well, it's not what's on laptops or high-end workstations, but the small computing clusters you may have at the department or at a supercomputer. This up here is HPC. What are other reasons? Well, often HPC centers like HPC2N has specialized or expensive hardware. We have a lot of GPUs, for instance, including optimized for AI. We have all these kinds of GPUs. We also have high-end CPUs with error-correcting memory. We also have software with licenses for many types of software, and the software is pre-configured and ready to use, which also is very nice. Then we have a lot of documentation, and we have support that you can ask for help. So I will quickly also say about what are some memory models for high-performance computings. And the ones that are relevant are the shared memory, where single memory space for all data. All the cores access the same data and straightforward to use. And there is distributed memory, where there are multiple distinct memory spaces. And that means that each only has access to local data and you require communication. And that is things like MPI. So shared memory is both in HPC and in small workstations, but it's within one compute node in an HPC computer or supercomputer. What is in there you would run in shared memory. So everything, if you have a large node with lots of cores, they would all have shared memory. But if you are running on many nodes, it would be distributed memory. So single core, it could be things like MATLAB, Python, C, Fortran, where there are single streams of operations. Multi-cores would be vectorized MATLAB, P-threads, OpenMP, multiple streams of operations. Work distribution, coordination, and synchronization is needed there. For distributed memory and for MPI, you have multiple streams of operations. You have work distribution or coordination, also synchronization. And now on top of that, you need data distribution and communication. If you then add GPUs, then you also have the data distribution across both memory spaces and movement. So there is a lot more to handle there, but often the software will already be configured to handle that. But of course, you need to ask for the correct resources in your batch job, and we will talk about that later. So I'm not going to go further into this.